And it should be the same link as before, right?
I actually need you to leave that alone.
Oh,
It's streaming
sorry.
that screen. I just left it as a placeholder, so if you can close that. Just go back to your presentation, go full screen for me. Thank you. Perfect. So the stream will look like this. Yeah, on this machine, can you just get another tab here real quick?
Yeah.
And go to your YouTube page. So just dogging.
It's like such an expensive computer, but it's shit. It's probably the graphics card. All right, let's see.
So if you just want to pop into your YouTube channel just real quick and look at it, make sure it's going, then you can grab that link and you can tweet that link out, and that way everybody can watch it.
Yeah, that'd be perfect. So it should be here. Actually, it says it's waiting. But maybe I'm not in the right one.
So this, what are you in here?
This is just our Notion. It's the old
go back
link.
to YouTube, please.
Yeah.
Sorry. Yeah,
So
that's the old one.
Live.
I think it got broken because you had pre-set up one, and then I wasn't connecting to that one, and so something got confused. This situation. I can delete that.
It's over there. Oh, wrong account.
Oh, jeez.
Oh,
dude, that's why. Oh.
Jeez. Sure. Oh, fuck. This is so annoying. Fucking A.
Okay. You want me to email you the link so you can treat it easier?
Yes, please. Yes. Thank you. Okay, we're pretty much good to go.
Waiting on anything?
Just setting up the live stream, and then we're starting now. Okay, so we're live. All right, everybody, I'm going to have to interrupt your stellar, intellectually stimulating conversations to transition into the afternoon session. So we have a great lineup of talks for you guys. I'm going to just pull up my notes here, make sure I get everything right. So we have 4 talks today. The theme is going to be on a public commons for discovery and innovation, and how Web3 uniquely positions us to be able to build one in ways that have failed in the past. So, we'll be asking questions like, what is decentralized science? We'll be exploring themes of deep dives on technologies pushing innovation, opportunities for funding discovery, automation of meta-science, emerging cultural motifs and trends, and overall strategic directions in the founding of an open and accessible Internet of Science. So we'll have a panel discussion followed after a series of 4 talks centered around the question, what is the objective function of science? And all attendees may qualify for a POAP. So if you haven't already, you can go ahead and scan that code and claim your POAP. So to kick us off, we're going to have Eugene come up and give his presentation on the Dsci landscape. And I'm going to go ahead and set up his slides real quick. And Eugene is the director of Ops and Community at SCRF, and he's going to be talking to you guys a little bit about the exciting activities we have planned for you, not only today, but in the future, right? This is just the first real DeSci meetup, and we hope that this can really build into a movement that becomes as autonomous as some of the other systems we're running on.
Thank you, Shadi. All right. Hello. For those who have been here since we started the Dsci events earlier today, this is round 2 of the talk I just kind of gave off the cuff because we were having AV issues earlier. So now I can actually show you the slides I put together. So thank everyone. I want to thank everyone for joining. I know it's really exciting times in Dsci with just how early stage all of this is. And when I was just trying to think of the way to present sort of what does the Dsci landscape look like, at least from my perspective, it also kind of doubled as what was my or our journey as the Smart Contract Research Forum into Dsci and the angle that we came at it from. So first, I just want to plug and mention Smart Contract Research Forum, which is where I work. I'm the head of operations there. And Smart Contract Research Forum is a grant-funded organization focused on advancing research in the Web3 space. More specifically, we provide grants to individual researchers to summarize their research to make it more accessible to others. And as our name implies, Smart Contract Research Forum, our core product, so to say, and I just put that in quotes because we don't charge for anything, but our core product is our actual moderated forum focused on long-term research discussions that are chain agnostic, that are just really focused on capitalizing on the amount of energy around various aspects of research. So for us, the starting point was very much creating this forum and an incentive for individuals to share their research. But as we started kind of going through that and thinking about future steps and how we can actually support the independent researcher landscape in the space, we realized that we were interested in much more than just this initial coordination, facilitation, and incentive layer for just Web3. So our actual starting point was we wanted to gather the list of some independent research DAOs that we were aware of that were specifically doing research in this space. So there's Other Internet, MetaGov, RNDAO, a few other projects, Governance, which is a project I'm personally part of, a few different groups looking at creating DAOs to research DAOs, nice and meta in that direction. And from there, I just started building this kind of a public list. And this is one that I'm happy to share with everyone. I'll have a QR link for anyone who wants to actually get in on it. But this is just a list I slowly started putting together. And it very quickly grew from a handful to 10 to now almost 40 different organizations that are doing Dsci in some kind of way. And so today, and this is, I'm not going to pretend this is a complete picture because I'm sure just in the couple of hours we've been here, somewhere on the planet has started a new Dsci project that none of us are aware of yet. But these are a variety of different groups, ranging from, I know it says Magna Carta Sciente, that's atoms.org, but there's a lot of different projects on here, some of which, Lab-DAO, Opsci, I actually realized I don't have the Manatee logo on here, but we have a bunch of folks who are actually here presenting, as well as a number of folks who are not able to join us in person, but they were able to join a public space that we hosted via Twitter Spaces the week before this EthDenver started. And we're going to start doing more of those kind of public calls to really gather the global DeSci community in person and virtually. And so I like splitting this general list of, there's the organizations that are thinking in this DeSci space of how do we apply Web3 tools to advance learning, research, review, etc., specifically in the Web3 space, right? So this is kind of an expanded list of the organizations that I started coming across that are specifically dedicated to attention and advancing research in the space. And, we heard Renee from Talent-DAO earlier. Tomorrow we're going to hear from someone from Governance, someone from RN-DAO, someone from MetaGov. We're going to hear a few of these groups actually directly present. And on Wednesday, for anyone who comes for the 11 to 1 session, we're going to hear an independent researcher give their research on the index co-op. And then we're going to follow that up with a panel on how do we provide peer review for someone like Jack who wants review, who wants to make sure that their work is actually sound and correct. How do we as a community rally around independent researchers and provide them open review? And then there's a whole list of organizations on this list that might not care about Web3 specifically. They're much more focused in other domain areas, and their focus is how can they use the tools of Web3 to advance science more broadly. So again, this overall map is definitely still a crude one. There was a lot more nuance that I was hoping to be able to capture into this in terms of, on the research side, who's just focusing on funding, who's providing a data stack, who's providing other kind of goods and services around it. And this is something that I'll mention in a little bit with some of the bounties that we have, but we really want to make these community managed resources. And at SCURF, we're thinking about how we can provide the incentives to actually make sure that the community is compensated to keep these kinds of lists updated. Because we think if people do work, they should be paid for any kind of work that they do, even if it's benefiting for a public good type of fashion. So we're going to hear a panel later that's specifically on the role of science. So I'm not going to belabor this point and purely give my own personal view. I like bucketing, and I understand this is overly reductionist for science, but my view is there's the research component. We want to add new things to a base of knowledge. There's the review component shown by that lovely kitty in the middle of assessing all the research that has happened to make sure it is sound and correct. And then there's the actual publication side. How do we share this with the world, not just in fat literal tomes that need to be through very formal channels, but how do we start thinking of disseminating this way, this kind of information in a way that is more accessible for everyone, not just for researchers and behind paywalls, but also in ways that the actual researchers will stand to benefit ideally far into the future, not just in the very beginning stages. So again, this is kind of the full landscape of DeSci, at least as I've been able to find it. If anyone here is actually working on a DeSci project that's not captured here, please come find me or anyone else, whether it's myself from SCURF, anyone from Op-Sci. I know we have DeSci Foundation, we have DeSci World. We have a bunch of these groups actually presenting and working with us. And at this point, I think we're connected to just about everyone besides maybe 1 or 2 groups on this list. So we're doing we're putting a lot of energy and focus towards actually building out this global community. And we want to make sure it's accessible as possible for individuals. So one thing, as I was mentioning, is if you want to contribute and just, contribute, if you want to be an editor on that shared public Google Sheet, you could scan this QR code and you could just see the Google Sheet, or you could request access. More than happy to share it with individuals. I made a tiny URL for it. And the link to this presentation will be in that Notion page that was posted in the DeSci Telegram. So yeah, there will be a few ways to find this, but please feel free to contribute to the sheet if you know of any other projects. But that sheet is actually just a thing that I put together for me to help kind of manage the list of organizations I was coming across. What I was actually really interested in is turning this into an incentivized community managed resource. So as part of that, SCURF has put up a bounty, a non-technical code bounty, where we just want to take that, all the information that's currently living in a spreadsheet, and let's make it into a tool that is more convenient and for a community to actually update, whether that's an Airtable or anything else, but just something that can be more convenient for people to actually manage and contribute to. And again, so we do have a bounty open for this. And if you go to that QR code, that's to the actual bounty information in case anyone's interested. We're going to give away a few $500 bounties for anyone who's able to help us at least just clean up that list, make it more usable, with the intention of then creating further bounties to actually create mapping tools around this and much better visualizations than my little landscape of logos that I was able to slap together at midnight last night. And from there, I also just want to make sure to plug the other bounties that Scurf is doing. So this QR code goes to our general list of 4 bounties that we have, the largest of which is a white paper on what reimagining what open peer review can look like. So no code required, just what you see a model for open peer review looking like. The largest bounty available there is going to be 1,500 DAI. Yeah, our actual intention is not just to do this once and then say thanks and goodbye, but for this to be the beginning of, again, building this community and adding to this kind of coordination and facilitation around all these projects. From our perspective, we're really most excited to just help all the different projects be aware of each other, understand who's actually doing what, and then thinking as a group, who else do we need to pull into this little new DeSci world so that we can get as much activity and progress as possible. We also have some other bounties on just summarizing some panels and writing on community. So yeah, please feel free to check those out as well. So yeah, what's next, right? This is we have 2 events today. We have the social tonight. There's 2 events tomorrow, 11 a.m. to 3 p.m. total. We have 2 events on Wednesday, 9 a.m. to 1 p.m. total. There's a DeSci for Space talk on Friday that we're not affiliated with, but someone else is organizing, and I'm just excited that there's more DeSci stuff happening. On Saturday, I'll be on a public goods panel, and I'm definitely going to be talking about Dsci and specifically trying to start exploring as a community what sustainable funding models can look like. And my personal view is I want to see if any of the wallets would be open to adding an opt-in tax system with full transparency, because it would all be on-chain, so we'd know where our actual donations would go to. And if we want to donate to Gitcoin, to Dsci foundations, to specific causes, right, how can we actually streamline the process for individuals to want to do good? But we ran our first Dsci community call. If you see the hashtag up there, that was just a Twitter space that Shadi and I ran on Friday while we were freezing and it was starting to snow in the art hotel. But the intention there is for this to become a community handle. For anyone that wants to host a public dialogue via Twitter spaces, please use that hash and reach out to us and loop more folks in. We just want to get as much public dialogue around this as possible. And we're going to be planning more events for anyone who's actually going to be up in Breckenridge next week. We're probably going to do a last minute planned social up there for any Dsci folks who want to chat. We're going to do a virtual Dsci day at some point in March. It'll probably be more of a half day, but we'll have a number of presentations, especially from groups who weren't able to present today, and to hear updates from folks who are actually here and presenting. And in late April, we're currently trying to plan an in-person Dsci day around ETH Amsterdam. So at some point the week of around April 20th, 21st, somewhere around there, we're going to try to do an actual on-the-ground in-person breakout where we will be able to get a lot of the core contributors together, but also just, again, keep expanding the community. So yeah, tomorrow, if you come by the event between 1 and 3, you'll hear me give an actual presentation specifically about Scurf and the work we're doing at the Smart Contract Research Forum. This QR code goes to our landing page, scrf.io, where you can learn more about the bounties. You can get to our Discord. You can get to our actual forum, which is just a discourse instance and very focused on the research side. And yeah, I'm always personally very happy to connect, hear who's working on what. We already had, I know there's already been a number of folks approached with like, hey, we're VCs interested in sciencey stuff, right? So we are just going to be trying to coordinate and collaborate and facilitate interaction to help this group as much as possible. So if there's anything else we can be doing, please always reach out. If you want to connect more, always feel free to reach out. And if you want some stickers and shirts, you can always find me in that corner. Well, not always. For the next hour or so, you can find me in that corner. But yeah, thank you very much for that. And I think we're slightly short of time, so I don't want to open up for questions, but please feel free to find me on the side if anything, and I will pass it off to Boris for introducing the next speaker. Thank you all.
Hello, everyone. My name is Boris, and I have the pleasure of introducing our next speaker, Shadi El-Damadi, who is just setting up the slides right now. So Shadi is a neuroscientist and an avid advocate for open science. He believes in the synthesis of human creativity, artistic expression, and powers of observation. He's working on tools for knowledge engineering to supercharge today's spirit of discovery and innovation. Shadi founded Op-Sci as a nonprofit organization to support the establishment of a public commons for science. Before I talk about what Op-Sci is and what Shadi will be talking about today, I actually want to add that the reason I'm here today is because of a very generous travel grant from Opsci. So it's really my pleasure to introduce Shadi. And today Shadi will be talking about the Opsci stack, which is building an autonomous internet of science. So Opsci is a community that's building out a framework for a decentralized public commons of research and discovery that elevates knowledge creators with the power to capture the value of their own content. Shadi's going to give a broad overview of outstanding problems within DeSci, and he's going to highlight some projects that are making significant progress on these fronts. He's also going to cover potential future paths forward and the importance of community collaboration and DAO to DAO coordination. Without further ado, Shadi.
Hi, everybody. Thank you. I'm going to try to speed through this a little bit because we are short on time. So we're all here today, I think, because we're concerned with broken feedback loops. Sorry, hold on. Broken feedback loops of value in research and development. And Opsci was centered around this mission for employing Web3 technologies to build solutions that allow us to empower knowledge creators as content creators in the same way that Web2 empowered other types of content creators like YouTubers or Instagrammers. But let's do this for knowledge, for things that actually make the world better, safer, healthier, and stronger. So, you know, we talk about decentralized science like it's a new thing, but maybe it's not. I think that science really was decentralized at its originations, where it started off. I mean, if we look at the Royal Society was a group of dudes, unfortunately, mostly, probably almost completely, that got together and thought about questions that were interesting to them, like why did the seasons change the way they did, or why did certain types of animals have certain metamorphosis stages. That's a hard word to say. And so since then, something has happened along the way, right? Where we went from kind of this gentle person scientist to these kind of social roles that you have to unlock through kind of these achievements, right? Get a bachelor's degree, maybe get a master's degree. And then today, I think like if I tried to apply for a PhD program, probably wouldn't get in, comparing like what people today have to do to get into science as a pursuit, as a professional pursuit. And so today, you know, we see other decentralized science communities like the brain hack community in neuroscience, which I'm very intimately a part of and probably put me on the track that I am today to be working in Web3. So the brain hack community is a decentralized science community. They meet multiple times in these ETH kind of community conference type sessions where there's hackathons all year round. But these individuals and contributors are not recognized. They are often working part-time to do this, or this is a hobby for them. And there's really kind of no strong incentive to keep this community together, or any social governance layer, or incentives really to kind of really promote and supercharge that movement. So I think a big problem, why this is a big problem, has a lot to do with what's called the appropriability conundrum. And that's something that Solo, he's a Nobel Prize winning economist, who identified a really interesting trend in GDP growth over time in developed nation states. And so if you try to fit different types of features in a linear regression model, looking at things like commodities, land as capital, human capital, there remains a residual that doesn't explain GDP growth over time. That residual was called the Solo residual. And he successfully argued and proved in some ways that this residual is really driven by basic science research. And so today, the model looks a little bit like this, where the government gets the ball rolling with public funding that's decided through committee or perhaps through lobbying groups to specific initiatives or strategic directions at the institutional level. So organizations like NIH and NSF, they identify what we kind of really want to do. And I think this ties in really nicely with the tech trees work that Allison is putting together that really innovates on this model. Like, what are the strategic directions? This money is given to scientists, and then scientists do the hard work, and maybe over a period of 10, 15, 20 years, this knowledge gets pushed out in the form of papers, data, code, protocols, scientific talks, and so on. However, as they're pushing this data out, people are looking to convert that basic science research into applied research and development research to produce products. And to do so, right, there's the value curator in the middle, or I'm sorry, the knowledge curator in the middle, that's extracting value both from the scientists by employing them for free to review their works or to act as editors, and also to charge them to publish to their own scientific journals, waiving sometimes copyright if in the case of non-open access publishing. And industry is on the other side, pulling out, putting money into these systems to be able to access this knowledge. So it's a huge problem, right? You have a huge value sink that has nothing really to do with the feedback loop of a society improving and innovating and addressing existential problems that only science can solve. So a really good case study of this and why this kind of is a huge problem, and to give some numbers behind the solve, is comparing the entire University of California system and looking at how much they make in intellectual property and royalties compared to something like Elsevier, a single publisher, which owns a lot of journals, but it's just a single publisher. It's an order of magnitude greater, right? So over all of the life-saving technologies, the different protocols, the different patents that the UC system, which contains multiple top R01 universities, UCSD, UCSF, UC San Diego, and so on, they're making 48 million, right? Meanwhile, Elsevier is just boasting with the largest profit margins in any industry. It's a huge problem because that money could be then fed back into science. So the question is, and I pose this to everybody today, how do we grow a self-sustaining knowledge creation community that is as prosperous as it is productive? So I'm kind of experimenting with a new framework here, which I'll just call the Open Science Framework, but that's already kind of taken, so it's the Op-Sci framework. And so Opsci is a nonprofit organization, and we're actually pending 501c3 status. It does take a while to get these things. And the mental model that we're working with is the nonprofit is the core, the heart, the ethos of the organization of the DAO. And the DAO is a permissionless kind of digital layer where anybody can participate in becoming engaged in decentralized science. And as products or different types of use cases emerge, like for example, publishing platforms or different variations of data markets, these can be spun off in a hybrid social impact for-profit, nonprofit model, very similar to the Mozilla Firefox Foundation, where individual spin-offs have some stake, are held by some stake in the Opsci nonprofit parent company or organization. And so the whole point of this really is to put together a core team of custodians, because we know that a DAO is really good at coordinating and solving issues that involve kind of like things that are more lent to crowdsource challenges, like Constitution DAO or like MakerDAO, like really well-defined problem statements. But like Open Access DAO showed, if any of you guys are familiar, it's very difficult to build a concrete product or solve a very specific complex problem. So we do need a core team of individuals that are and that have stability, job stability. They're not just part-time contributors. And I know there's some of you out there that quit really high-paying jobs and you're living kind of a little bit less comfortably than you like just to work in DAOs. And that should be the case. We should have a nonprofit framework to fund these core contributors so that we could empower individual members through DAO citizenship, right? So voting, through mentorship to address kind of a huge problem in science right now, which is how do you actually convey knowledge and allow people to thrive and grow, and that's through mentorship, scholarship, right? So to continue to contribute, fellowship for advanced research, and activism, right? So a lot of the things that we could be doing actually needs to be in interface with the centralized traditional system. So I'm going to talk a little bit about what we've been focusing on, really something, I don't know if this is a novel term or anything, but what I call data kintsugi. So we've identified a huge unstructured corpus of data out there, and we figure that let's start by consolidating a lot of the scientific data that we use to do research and to build a better commons for that. So how do we go from unstructured corpus to an interoperable federation? And under this, we're looking to engineer a positive feedback loop. So how do we go from open access knowledge that's then translated to private applied research, which could be used for products and services? And I think the key here is that we need to tap streams from the basic open access, from the basic science and open access research to products and services through public goods fees. And that's something that smart contracts can help us realize. So in a little bit more detail, we can start thinking about a regenerative data commons. So this is a knowledge marketplace that enhances the appropriability, solving that conundrum that Solo discovered, of digital basic research assets in the research lifecycle. So this is a little bit, if you want more detail, you can talk to Jakob about this. He's actually building a software toolkit that allows us to simulate different variations of this to converge on different models. And the idea is that there is no one right model, and we need to experiment and try many different ones. So I invite everybody to contribute and take a look at the software package and see if it meets your needs, and if it doesn't, do let us know. So the goal here really is to have a treasury that funds open access research. And the agreement is that if you are funded, you are publishing open access. And we'll provide public cloud service infrastructure through a middleware called Ocean Protocol, which allows us to basically sell data storage or compute to private providers or private researchers. And so private researchers want to access open access data. Maybe they can download it for free. Maybe they can read its contents. But if they want to interact with it in any rich or complex way, they're going to have to use these cloud services, and they're going to be paying some fee that goes back into the treasury. This is just a working model. Would love to get all your feedback on it. So this, going into a little bit more detail, we can start thinking a little bit about a verifiable chain of discovery. And again, this would be built on a DID identity protocol like we talked about before. So where you have an individual, a scientist, who makes a prediction. When they make that prediction, they're minted probably in ERC 1155, but we'll leave the technical talk for after, a research project. And that research project has some associated metadata in it, like title, hypothesis, design. And then when they deploy their experiments, they'll do so through a web portal. And this is a tokenized protocol. It could be a wet lab protocol, like a PCR procedure, or it could be a workflow that's encapsulated in a containerized environment, like through Docker. And so these individual tokenized protocols could be separated into raw and derived data. And this raw and derived data is then published on a data marketplace. This way you have provenance and structured metadata all along the way. So let me just quickly share with you our roadmap, where we've started and where we're going. So so we're doing a lot of research and development, talking to neuroscientists and trying to understand their cloud services needs. And as part of that, we want to onboard hundreds of terabytes of data onto Filecoin and build a knowledge graph that allows individuals to make contributions, have that verifiable proof of discovery and research, making their predictions, and cloud services that run in the cloud and that are able to run analyses in the cloud on containerized experiments. So right now we're building out a pipeline that allows us to crawl the internet, crawl metadata aggregators for scientific repositories, and archive that permanently for free using Filecoin Plus. So that's one part of our approach. The other part of that is a knowledge market that allows us to sell computation to private interests or private researchers. And lastly, we're looking at how we could think of a token community pilot to track the value of knowledge commodities using an abstraction of the token. And then later on, maybe 5, 10, 15 years, who knows, we'll be seeing things like executable research papers where high-resolution 3D reconstructions of bodies, of organs, of proteins are interactive NFTs with metadata that are linked to the identities of the contributors that performed all the hard work, which allows us to think of contribution incentive mechanisms that go back to the root. And lastly, we're visualizing this Web3 science commons that has autonomous agents that are curating and republishing data that are guiding us to perform guiding us along threads of strategic directions in research, and taking out some of the hard kind of soul-draining work of doing science, right? Which is all of this administrative work. We want to put researchers to work. I'm going to skip over this part and just really quickly highlight some projects in the ecosystem. So we're working on a decentralized data marketplace built on Ocean. It's called Coral, kind of in recognition of all the great work that Ocean has done to support us. And this is basically a proof of concept or a demonstrator that we can show the scientists and say, would you use this? Or is this something that solves your problems? We also have a toolbox for simulating token economies. I mentioned that a little bit earlier, and if you have any questions, talk to Jakob about that. We're also working on a platform for preprint archival on ARweave and Filecoin, and thinking about how we could unite all of these three with a DID, DeSci DID. And lastly, we're also collaborating with Manhattan Protocol for a payment solution to be able to split payments and to set programmable split payments for intellectual assets like papers, curated collections, data sets, even code like Jupyter collections of Jupyter notebooks. So kind of exploring different avenues beyond just ERC20 token automated market makers like the Ocean protocol. Yeah, so looking forward, we're currently seeking funding to launch our third cycle of open web fellowships. All these projects have come out of basically public goods funding to sponsor fellows to research these topics and build these applications. We're going to be scaling dataset archival. I'm working on a hackathon project this week for Open Science DID. We'll also be linking that into Manatee protocol or exploring potential integrations. We'll be publishing scholarly content along the way, so keep your eye out for a couple papers in some academic journals, hopefully. Yeah, we're here at EthDenver. So yeah, so here's the collab. I don't know if that link is up to date actually, so please ignore it. If you want to learn more, there's Opsci.io, and if you want to fund the next cycle of grants, do take a look at our Kickstarter page. Thank you.
Thank you, Shadi. So up next, I'm going to introduce you to Nicholas Rintor, who is a brilliant physician scientist who's based in Berlin and on the East Coast. He's interested in answering a lot of really exciting questions, and today he's going to be talking to you about a project he started called Lab-DAO, which is a community of scientists that are exchanging laboratory services with each other, and he's also a core member of Vita-DAO, which you'll be hearing about in a little bit. I'll leave the rest to Nicholas to talk about, and I will say that though Shadi is the reason I'm here at EthDenver, Nicholas is the reason I went down the Web3 rabbit hole in the first place. So I think you're going to love what he has to say.
All right. Well, thank you, Boris, for the kind introduction. And thank you, Shadi, for inviting me over. I'm super excited to talk about Lab-DAO. So at Lab-DAO, we believe that open tools accelerate progress. And I think one key example in biology where open tools have demonstrated to accelerate progress was really, I think, the birth period of molecular biology, the way that we know it, which were the phage courses at Cold Spring Harbor right after World War II, where scientists would come together and they would share the actual method of how you could study the interaction of bacteriophages and bacteria. And this is just one example from these original sort of open source scientist communities that would share information in a very pre-web way, which consisted of actually having in-person courses and sharing books and selling them to each other. Now, there's one problem, however, when we think about sharing instructions about biology. And especially when we compare that to the way that we share instructions about code. I think over the last 20 years, we've seen an explosion in progress in information technology because engineers at technology companies insist on being able to work on open source projects, and they share code in an open source fashion, which is iteratively and continuously leveling the playing field every so often for everybody in the ecosystem, such that Facebook has a really good JavaScript front-end library. Then they launched the open source JavaScript front-end library. Suddenly, everybody has a great JavaScript front-end library. We need something like that for biology. However, the problem is with code, it's a very low cost of execution and a very, very high problem of very high reproducibility of code. While in bio, you have a very high cost of sharing your instruction, actually running it, and a very low reproducibility. So the problem is, how can we make doing bio feel a bit more like doing code? And I think if we want to take a step back, we can also look at the current DeSci stack and what projects are already out there that I think are trying to accelerate the pace of science. And I think there are these three functions that we have in science general, which is you need to have funding for your science, you need to have some way to execute the scientific experiments that you've been defining, and then you need to have a way to distribute your insight. And there are a couple of projects that have already been mentioned today that I've presented. or that are getting started that cover, for example, the funding, Vita-DAO, their science funds, Gitcoin, and other projects, and the distribution of insights, such as Opsci itself, or Molecule that takes a bit of a more translational medical approach. However, what we believe at Lab-DAO, what's missing is an execution tool, a community that's comes together to actually try to build the tools that are required to make decentralized scientific experimentation happen and laboratory services be available to everybody, no matter in the world where they are. So how are we going to do that? Well, step one is to enable an open exchange for laboratory services. Something like a Craigslist or an Airbnb, where I can offer an API, I can expose an API for a particular laboratory service, and I can have other people pay me in tokens for me to do the laboratory service, and I share the data with these people on chain. So everybody knows that this work was done, and there's a very low risk of experiments being repeated unnecessarily. Now we're going to start out with the easy stuff, which is dry lab services, actual compute. So for example, you give me an amino acid sequence and I fold you the protein using AlphaFold, and I deposit the PDB file in my BFS, mint that into an NFT, send it your way. And once that is obvious, there's a cash flow release from an escrow contract, and I get paid for that. And the whole world knows that you make this API call. Actually, everybody can contact you if you decided to encrypt that information and purchase that data from you, maybe using tools like the one that Shadi is working on with Opsci. But I think this is just the beginning. There's so much more cool stuff that we could do. Also in the wet lab space, where when you're in a space like Boston, why does everybody do their PCR cleanup themselves if there could be one nonprofit lab spun out that just has a couple Opentrons set up and they run this in a nonprofit fashion, or perhaps also for profit? Now, that sounds really messy because we all know in bio that the results that you get out of a particular experimental laboratory services are not very reproducible. And one of these sources of noise is the fact that the instructions and the way that we do things are not very standardized. So step two is that once you have an exchange, I believe that the cost of arbitration for conflicts is going to induce standardization. Now that might sound a bit complex at first, but let me just give you an analogy. If I'm paying Chris to purify a protein for me, and I'm not happy with the result, it's going to be very hard for Lab-DAO to be the arbitration service, to be the jury and say who was right and who was wrong in the way that the purification was happening. However, when Lab-DAO itself as a community comes together and say, well, this is the standard on which we agree how purification is being done, and every vendor that adheres to that protocol will be arbitraged by us. So we are going to be the jury for people that adhere to this protocol. We settle conflicts for people that adhere to this protocol. Then the transaction, the market functions better, and as a second order effect, we actually have standardizations. So perhaps all of these like deep tech services can feel a bit more like applications that I can just invoke. And one good example in history is the shipping container. We didn't have a shipping container until we had a lot of transactions, and I needed to rely on someone else to be able to put whatever I want to put on a ship on the ship in a very simple and abstractable manner. Step three is once you have an exchange in which laboratory services can be traded, and you have market incentives that push the participants towards standardization of services, I think there can be a knowledge graph that emerges, because suddenly, if I use the standard protocol to purify a protein from Chris, but I also use the same standard protocol to purify another protein with Akash, suddenly we have two leaf nodes and one common stem, which is this protocol was used for 2 amino acid sequences, and these are the data sets that came out of that purification. So suddenly you have actually a knowledge graph. You have a graph that you can query, and ideally also data that you can consume to actually figure out something new about life and science in general. And I think this is going to be a key element to get us to the Dsci future we all want. We want to live in a future where everybody is empowered to raise funds for their scientific or entrepreneurial project, no matter where they are. We want to live in a future where everybody is enabled to run laboratory services independent of in what city they just happen to live. And we want to live in a future in which data can be shared and materials in a way in which it is fair both for the person that shared the information, but it's also accessible for everybody and for the rest of the human future because it's decentralized storage. Thank you. We're building Lab-DAO right now. It's not yet decentralized. There's a centralized launch team. If you're interested in helping us build Lab-DAO, come check out Lab-DAO.com or talk to some of the Lab-DAO folks in the audience. Thank you.
I don't know where the presentations are, but yeah.
Also have to turn it back up so you 1 second. Sure. Hopefully that'll keep when you guys turn your head to look at that. Oh, yeah. Then you're still on the link. Yeah.
Amazing talk, Nicholas. Thank you again. Up next, we have Kat from Vita-DAO. If you're not familiar with Vita-DAO, super cool project that fits into the first part of the scientific stack that Nicholas just described. And Kat's going to be talking about how Vita-DAO finances longevity research and generates intellectual property as IP NFTs in an open and democratic manner. Super cool stuff. Please welcome Kat.
Thank you, Boris. I do mostly operations for Vita-DAO, and so in Vita-DAO, we want to create a world where longevity therapeutics will be funded, owned, and governed by the people who are directly benefited from it, so the patients and the general public. And so to achieve this, we have to create new open structures to move away from a world where this is done by centralized, inaccessible institutions and into a more decentralized organization. But why crypto and longevity? So crypto and longevity are both at the forefront of really new fields with potential to be transforming the conversation. Both have been dismissed by traditional institutions, so crypto by TradFi and longevity by current healthcare systems, by existing research institutions. We consider aging as a normal fact of life. We don't think about it the way we think of diseases like Alzheimer or cancer. But there have been recent progress. So in January 1st this year, only more than a month ago, we have the International Classification of Diseases classified aging as a medical condition. So it's not normal anymore, it's a medical condition to be addressed now. And I think this speaks to the increasing attention the field is receiving. And within crypto itself, we have a substantial overlap between people who are interested in crypto and people who are interested in longevity. So comes Vita-DAO. We fund early stage, high risk, high reward longevity projects with funding in the size of $50K to $1 million. The decisions in 2 to 3 weeks is aspirational at this point, but we're getting there. And to me personally, from personal experience, the uniqueness of Vita is in the last 2 bullet points here. So up to very recently, only maybe 6 months ago, longevity felt very inaccessible. And so I don't have any background in bio, I'm not a scientist. And even though I had a long-term interest in longevity, it felt inaccessible to me. If you don't have a PhD in biology or a related field, or if you don't know the right investors, it was very difficult to be taken seriously. But Vita-DAO is a DAO, so you can just jump in, you can just start doing work, talking to people, and as long as you can prove yourself to be a reliable contributor, contributing meaningfully to the community, we would welcome you to the community. And it is a very diverse community. We don't just have crypto people, we also have non-crypto people, like technical writers, researchers, academics, people who otherwise wouldn't be doing anything in crypto right now. So at a high level, this is how Vita-DAO functions. It's been like this since the beginning, and it's pretty static. At the top, you have DAO members. They contribute funding or work in exchange for governance tokens. At the bottom, we use the tokens, we use the funding to fund longevity projects. It says lab here, but we fund research lab, company, individuals, anything promising really. From these projects, we get back data, and we commercialize this data through Ocean Marketplace or other decentralized data marketplaces. We currently don't do this yet because we don't have any data yet, but it's coming. From these projects, we also have intellectual properties, which we then made into IP NFT. And these IP NFTs are governed by the DAO. Okay, so DAO members can get together and vote on whether to sell the IP, or to not sell the IP, or to license the IP in whichever terms that they put it. And it doesn't be for profit either. And so if DAO members get together and decide that a particular IP is better served in the public domain, we can also do that. We can also just vote it to be in the public domain. I want to talk a little bit more about IP NFT. So there are a lot of information on the slides, but the important thing to take away here is that IP NFT are natively on-chain, and so you could trade it, you could track it who's owning it, just like you can track on-chain objects. But we can move beyond that. Right? So we can collateralize it to borrow against the IP to fund further projects. We can also have transparency towards who has access to these IP, who has access to these data, and how it is currently used. And we can also incentivize creators and scientists toward discovering new IP by having terms such as a royalty, a kickback, every time the IP is traded or commercialized. All of these things are currently being done with NFTs right now, like with just JPEGs. There's no reason why we can't do it with a discovery of a new molecule, for example. A closer look into what an IP NFT looks like. So from the left to the right, you have a legal contract in the real world. This is just a contract that points to the Ethereum address and also specifying a real-world entity that owns the Ethereum asset. Then on the Ethereum address, you have the wallet addresses of the owners and the asset on the Arweave chain and all the transactions related to it. On Arweave, we have the metadata around the IP. And the IP itself is encrypted and stored, so no one can read it. As for governance, we launched not very long ago, and it was a initial fair token launch. It was fair in two different ways. So the first way is that it was not a first come, first served, where everyone is scrambled to buy the tokens as soon as it was launched. We launched through a Gnosis auction, which is basically you start it out with the highest price, and the price keeps decreasing, and at any point you can buy the tokens. So anyone had a chance to buy any number of tokens they want at the price that they think is appropriate for them. And the second way is that there was no pre-launch, there was no pre-sale, so we didn't sell any tokens to insiders, we didn't sell any tokens to any VCs. It was 100% going out to the community. In terms of governance, we have a 3-step governance process. And we apply the same 3 steps to our decision to how to fund deal flows. So at step 1, ideation, we have DAO members, source deals, and shepherd the deals through the initial applications. And then we have other DAO members with expertise in longevity, review the projects and make funding recommendations. So that's step 1. And then at step 2, we put the funding recommendations in this course, and there are further discussions, and then we vote through a 1-person, 1-vote system to whether to advance it to phase 3. And then at phase 3, we vote on snapshot through a 1-token, 1-vote system as to whether to approve the funding proposal. And so you can see that phase 2 and phase 3 can balance each other out through different voting mechanisms, so that no one, no one person or no one token holders have too much influence. At the moment, this is what our pipeline looks like. We have 4 proposals in phase 2, none in phase 3 at the moment, and we have 5 proposals that have been passed. These are projects that have been funded. On the left, the molecule is the very first project that Vita-DAO funded. This is the Genesis project, also our very first IP NFT. We don't just do for-profit, we also do non-profit funding. We had a Bitcoin round a while ago. We raised over $700,000 with 400,000 matching from Vitalik and from other people. And we use that to fund a bunch of other nonprofit projects in longevity. So if it sounds interesting to you, you should get involved. You can join our Discord. You can join a working group. We have a lot of working groups. You don't have to have expertise in longevity or bio. You don't have to be a scientist. I'm not. And if you are a researcher with a relevant project that we may want to fund, do reach out. If you know any projects that may be interested in being funded, we have a bounty system for referral as well. I don't have a QR code or anything, but you can go to this website, and our Discord is on there.
Thank you, Kat. Next up, we have Evan Miyazono. Oh, okay, sorry. I'm going to do the intro, but also we need to adjust this mic stand, and we'll maybe let Evan get the presentation pulled up. Okay, good.
It should be just right here.
I'll just use my voice for now. Oh, never mind. I'll switch back to the mic. So Evan leads meta research and mechanism design at Protocol Labs, providing long-term direction and helping to drive ambitions in our mission to improve humanity's computational and communication technologies to move humanity forward. This includes extending existing technology with new research and developing better tools for incentivizing and coordinating research. Prior to joining Protocol Labs, Evan completed a PhD in applied physics at Caltech, developing hardware for a secure quantum internet. So the pitch here, what Evan's going to be talking about is a question. If memes evolve like organisms, then this will be a 10-minute microbiome transfer from my mind to your mind, covering highlights of what Protocol Labs has learned about permissionless science in theory and practice, and weird things that they want to try. Evan.
Thank you. Super excited to be here and talk to you about this. This is probably going to go through a lot of ideas really quickly, and overall, I hope that I provide some interesting directions for everyone to do a little bit more exploration of efforts or things that I have found in my exploration of decentralizing science or accelerating science in the last few years that I've been trying to do essentially that for Protocol Labs research projects. So in terms of who Protocol Labs is, for those of you who don't know, we have been trying to do for data what I would say Bitcoin has done for money and what Ethereum has done for computation. We have created the library that is the transport layer for Polkadot, ETH2, and Filecoin. We created Filecoin, IPFS. These are names that have been coming up, but the idea is permissionless, self-sovereign, decentralized storage, where you have cryptographic guarantees that your data is being stored. And as far as who I am, I spent 6-some years trying to build a provably secure quantum internet before deciding that I wanted to work on something that was more immediately and broadly impactful, and ended up building, ended up helping out on building Filecoin. If you've come across proofs of replication, they are not my idea, but most of the figures are actually things that I made during my first or second week at Protocol Labs. It was a heck of a transition, getting sucked into the crypto world. And at this point, what I'm doing is organizing, leading, supporting research at Protocol Labs. It started off as grant programs and became how do we accelerate scientific progress in the fields of distributed systems, networking, and cryptography, which eventually became less associated with Protocol Labs projects and more associated with how do people think about measuring the rate of progress within research? How do you accelerate that progress? And so I've come across a bunch of different things, and one of them that's particularly interesting relative to the fact that Protocol Labs is really focused on decentralization is the fact that if you look at how research has been done in the past, it's essentially all been, especially the biggest efforts, this really top-down model. Yes, there have been great examples shown over the course of today of this like bottom-up independent researcher development of great scientific ideas. But if you look at things like the Manhattan Project or the Apollo program or the Human Genome Project, what you're seeing is someone with a lot of clout and a giant bag of money who picks someone, and you just see this hierarchical chain develop, even though what started with one letter and eventually became a huge number of sites. You could imagine this being the kind of thing where instead of being directed from the top, you could imagine having more bottom-up, more self-assembled interactions where it ends up taking a more peer-to-peer form. And you have to wonder that if this did take that form, if we still would have ended up in the same place, or if we could have ended up somewhere much better for projects like this. And generally, you'll see a clear analogy between the top-down versus peer-to-peer structure in top-down versus self-assembled structure for projects that you see in corporations versus DAOs. And I tend to put corporations, DAOs, and like governments on kind of embed them in the same problem space, because all they're doing is coordinating large amounts of collective labor and eliciting preferences and organizing directions. If you compare this to the kinds of things that you see in distributed systems and networking, you can match this to the fact that we are, in the world of blockchain, building all these protocols that are identifying ways to coordinate specific types of work, always things that are computable, always things that are based on like pseudonymity, anonymity, cryptography, tools that we know very well computationally. But there isn't a big reason why, if you took these principles and mapped them onto science as software that runs on the hardware of people with some like very messy firmware layers in between, that you couldn't see the same kinds of pros and cons when shifting to a decentralized system. So you should expect things like more robustness. You should expect better outcomes from having a more democratic process. I feel like you're familiar with all of these things. But in order to give a bit of depth on things that I found particularly useful for my understanding, I point to a bunch of memes that I have found useful in the Dickensian sense, these ideas that are infectious and transfer. One of them is this book, Reinventing Discovery. For those of you who haven't come across it, those of you who don't know Michael Nielsen, he has written both the most used machine learning textbook and the most used quantum information textbook. He also wrote a book about what research could look like in a hypothetical future where it's highly collaborative, highly networked. There are a bunch of fantastic examples that he goes through, like the Polymath project, or this Kasparov versus the world, which Gary Kasparov later called the greatest chess match in the history of chess, I believe, in which he played a forum where the move was democratically selected. And so this book does a great job of identifying great examples from the past that you can draw from, and why those examples succeeded, and what failure modes they may have had. And so if you're thinking about setting up some kind of collaborative scientific platform, I would definitely recommend this. This is kind of just turning into my book recommendation list, but I feel like I haven't seen a lot of that. And if you could boo me off the stage if you want me to stop at some point. But Cycles of Invention and Discovery, another great favorite when thinking about science as a system. There's a distinction between basic and applied science, and this book starts by breaking down why that has been harmful. It goes over the Pasteur's quadrant and this framework, and explains why this also can be detrimental to the rate of scientific progress, and it tries to propose and motivate this framework of invention and discovery, where the type of work, the type of expectations, the type of schedule that you can work on and make progress on looks very different between these two, but there's definitely not like a pipeline model where one leads to another. They're highly interactive, and I would say it's very useful to have as a mechanism, or as a mental model when approaching scientific systems. I'd also point to, speaking of systems, either this book or the blog post Leverage Points by Danilo Meadows. If you've ever wondered why, I guess some of you have come across Meditations on Moloch, the Slate Star Codex post after which the Moloch DAO is named. This is an alternative perspective from someone who studies the formalities of the incentive networks that result in Moloch arising. It's a very convoluted sentence. If I were going to disentangle it, I would say that systems have huge numbers of interactions, and when the numbers of interactions become too much to track, you can end up with behavior that ends up very strange. But you can look at that system, and if you want to change what it does or how it acts, you can follow this hierarchy outlined in this blog post or in the penultimate chapter of this book, and understand how you, change the way you think about affecting a system to become better at affecting the system for the same amount of effort, or having being able to exert less effort to extract the same amount of change in the system. I would also point to the acknowledgement that we are not the only ones who want science to work better. It turns out most scientists want things to work better, and most people who work in funding agencies and things want science to work better. Chesterton Spence is a great thing, if you haven't heard of it, to just be aware of. Try and think about why there are these inefficiencies that you're recognizing, because they're probably there for a reason. They were at least there for a reason at one point. And there's also the framework of wicked problems. Wicked problems are very valuable to understand as a reason why it can be very difficult to take on a problem like fixing science without a clearer success criterion there. Beyond that, I would say that I think we've all kind of generally recognized that incentives, and I think it's been mentioned one or two times earlier today, there's a lot of uncertainty about the future generally. We've been entering more chaotic times. I think that whether or not this plot on the right is accurate matters less than the fact that a lot of people feel like the plot on the right is accurate, because it leads people to do a lot of things like sacrificing to protect their jobs or their livelihoods, or doing things that generally don't carry a lot of risk. And my claim is that we are essentially sleepwalking to dystopia. We have everyone following their own little incentive gradient. And if you were to look at the flow of water, it really takes a lot of foresight to be able to see that you could wipe out a village, or with a very small, high leverage action, prevent this village from being flooded if you take action far enough in advance. This is a property of chaotic systems generally. If you, as a weird tangent analog, I think that we could potentially, as humans, get good enough weather prediction that slight modifications, or I guess massive modifications in human behavior that would be unnoticeable to the populations, like shifting what altitude planes are flying at, or flight paths, or the paths that tankers take, could cause noticeable changes, what could cause predictable changes in future weather phenomena. And if we had prediction at that level, we could have weather control. So total tangent. I do think that being able to predict farther in advance is very valuable. And I would say that even though the people in this room clearly all agree that we want better science, we want a better world faster through science and technology, I think that most people, I think it's safe to say most people got into science, the establishment, academia, large-scale funders for exactly the same reason. They want the same kind of change. And so the question becomes, how can we, as a smaller group with less funding, make the same, or have more leverage to help them do the kinds of things they want to do? And so one of the things that we're looking into, additional example of people who are probably making bad decisions for good reasons, and a fantastic talk about how corporations are the original AGIs and paperclip maximizers. Also, these slides are embedded in the Notion. You can get these slides from the Notion page. And so all of these you can find at other times. Additionally, I would emphasize this framing of Hanlon's razor, which I prefer. Hanlon's phrasing is never attribute to malice, which can be attributed to, I think, stupidity. Yeah. And this one that I like more is that misunderstandings and lethargy perhaps produce more wrong in the world than deceit and malice do. At least the latter two are more certainly rarer. I don't think that a lot of people in these systems are stupid. I don't think they're malicious. I think that oftentimes they're just chasing incentives because those are the only ones they feel comfortable chasing. And so it's great getting groups like this together who are ambitious and risk tolerant, because I think we can take a few actions that might be able to create more foresight and better change. My mention of foresight is not serendipitous. We are collaborating with Protocol Labs, and my team working on commons funding mechanisms is collaborating with the Foresight Institute, sponsoring this MapSnap competition to try to help people working in science. This is funders, but also researchers, entrepreneurs, investors, to identify the progression that technology might and likely could take and help us select what path we want that technology to take, because some of those paths are not leading to good places. Additionally, once you have that, I think it's really, once you have a set of technologies that could be developed and maybe some that shouldn't and others that should, it can be very valuable to do more than just put a grant or a bounty on it. Those mechanisms exist in the world. People have been using them for ages. We've started a conference that we're holding quarterly called Funding the Commons. You can see the videos from the last one. The next one will be in March. If you have mechanisms or funders or builders who would want to get involved in this, please reach out to me. I'll have contact info on the last slide. And overall, please think about all of these novel ways you could incentivize things and incentivize progress on the right projects. Not all incentives are monetary. Most, in fact, in science especially, are reputational. And so that's an important thing to keep in mind. There are things like competitions, or there's a big talk on the S process, which is a great way of maximizing, well, it doesn't quite maximize utility for a set of investors and funders, but it comes as close as we might be able to come given like computability constraints. I probably don't have time to talk through my secret funder model, but if you're curious what secret fund, if you like hidden identity games and you could imagine applying that mechanic to trying to incentivize collaboration in science, that's the overarching idea. Come find me afterward and I can talk through it in more detail. And other than that, I think that's probably my time. I don't know how fast I talked, but this is also probably a good slide to take a picture of. If you're taking pictures of things, I have a lot of recommendations. But again, you can find all of these. I don't actually know if I have time for questions, but I will be around for the next few days, always wearing a Protocol Lab shirt of some kind. Thanks so much.
Yeah, let's take the questions for the panel discussion, which will hopefully be an interactive discussion. You guys can be engaged. We're going to just take a couple minutes to change the room up to facilitate a panel discussion, which involves some workings with the live stream here. So just give us a couple minutes. Do grab some coffee, go to the bathroom. We'll be having Patrick Joyce, Evan, Allison. Am I missing anyone else? Oh, Nicholas. Yeah, sorry, Nicholas. He knows this as well. And I'll be moderating the discussion, so hope to see you in a couple minutes.
Yeah.
I got lucky enough to get body shit down. Like they had crashing at the house, like they were all still sleeping, laying on the phone, and they just like saying, like we step up to that. So, is there anything that's going to be up on the screen during it? I don't actually know.
I have to pee so bad.
If
you want to the restroom, I'm happy to.
Yeah. Eventually, we'll have like a good way of doing this so that it's automated. Yeah, I had to walk through my computer and I have like all this code running in the background. It's like making my computer run slow. I was like, wait, no, maybe I shouldn't be running like some analyses in the background while this thing is going. So definitely could have done it a little better, I think. So we can see that.
Okay,
I'll be right back. It just should, like, I don't recall that happening on your last USB-C form. Might be finicky and maybe swap the two. Here, swap these two. Maybe not. We just, I think two, just do two and have them share between the plug into the other one too. You already plugged into the other? Yeah. It's good?
I'm not ready yet. I don't know why. It's not picking up. I think the microphones would be a simple thing. It's all they were muted.
All right, our time in this space is winding down, so I'd ask you guys to wrap up your conversations and the panelists to come up to the stage, please. Patrick,
I got it.
oh, I see. Is somebody in the bathroom? All right, we'll give it a couple minutes while everyone comes out of the bathroom. We'll get started in a couple minutes.
Yeah, I think that's not over a lot of stuff. That was a great talk. I have a lot I need to talk to you about.
So many opinions on so many things.
So many opinions on both sides. Maybe we can start this conversation a little bit here. I think it's the right group of people too.
Thank you. Yeah, if there's anything that was missing, let me know. It's surprisingly old, and it's still relevant. It's a depressingly relevant for something that was like written 20 years ago and trying to predict 15 years in the future. It, like, I do believe that.
So here's a pro tip. This is directional, so get right in front of them.
Breakthroughs in
I'm going to put it right.
decentralized coordination that could make that far more likely to be achievable.
Watch your step.
I was going to stand. So the focus will be on you guys. I'll be giving questions. Let's get started.
Meditations on Moloch framework with inadequate equilibrium, with complex systems.
Panel discussion.
They are the same.
This will be an open conversation. So I'll start off with a question. Each of the panelists will take turns answering that question in whatever way they want to interpret it. And then we'll open up to the audience because we didn't have much chance for questions because how smushed everything was with our AB issues earlier. So thank you everybody for coming. Huge shout out before I dive right into this, by the way, to Eugene from SCRF. This event would not have been possible without you. Everyone else. And Allison as well, thank you so much for looping us all in.
Thank you, Shadi, for taking the question.
Yeah, so this panel discussion really was a question that came out of our Op-Sci DAO hall, of our community call meetings. And it's something that we've been debating. What is the objective function of science? And this is really important when we think of autonomous systems like Ethereum, which is a smart contract platform that has some immutability associated with it. When you deploy systems to it, you can't really take it back. So thinking carefully about how we want to deploy any autonomous system on Ethereum, not even just a token or a financialization system, but other issues. And I think thinking about tech trees, thinking about the sleepwalking towards dystopia, thinking about how we provide proper incentives for research and how we build laboratories that can communicate, coordinate, and be adaptive around complex, difficult problems. So I'd like to maybe start off with Evan. What is your take on the question? What is the objective function of research?
So I might be a bit of a pedant in that I would distinguish the objective function of science with the objective function of research. I think that harkening back to memes that I just dropped a few moments ago, I think that I like the separation of invention and discovery. I think that there's some like exploratory understanding of how the world works that can be hugely beneficial and can only be achieved with like purely curiosity-driven exploration and cannot be achieved on a time scale that's predictable and like nighty and uncertainty all the way down. There are also systems where like if you don't know about the original skunk works and how they managed to like create massively innovative aircraft on absurd timescales, sometimes even under budget, you should acknowledge, like you should look into that if you are unfamiliar and realize that like, that's a super valuable thing, like mode of work that needs to exist. Both of these get called science sometimes. Both of them get called research, I think, more accurately. And I would say that to the extent that like, I should shut up and answer the question briefly. The objective function for science, in my opinion, is to understand the how and why of everything, and of research or invention would be to, I guess, to the extent that sufficiently advanced technology is indistinguishable from magic, the goal of research generally should be to fill everyone's life with as much magic as possible.
That's a really good way to put it. Actually, I think Matt Ridley distinguishes between innovation and invention, where, if I get it right, innovation is this curiosity-driven, more scientific process, and invention is the process of taking what the discipline of science or research has generated and then solving an engineering problem. So I tend to think about it as science is the art of asking the right question, while engineering is the art of finding the right answer to a problem. And this is maybe a bit oversimplified. I think they're sort of taking a step back here and trying to answer the question myself. I also have to kind of weasel out of it, I'm afraid. I think it's extremely dependent on what the dominant meme in the society is that wants to engage in research. I think before we had the Enlightenment, theology was considered, and is still today considered, a form of research, and it was, I think, at that time considered a very prominent form of research, and it's the inquiry of scripture. I think when we think about science today, it's a very humanism-informed definition of science, Enlightenment definition of science. We do believe that the hard sciences are the ones that can be traced all the way down in the stack of reality into like the information theory math layer, and then math goes into physics, physics goes into chemistry, which is just like, electron physics, and then into biology, which is just a lot of molecules doing interesting patterns. So what is science, what is research, is really dependent on the society that wants it. So it actually becomes a real societal debate. What is the objective function? And I would be really afraid of putting like a lot of capital, concentrating that into one smart contract and claiming that, we got this whole room together, we decided what the objective function of science is, and then we just call it a day. Because that, as a society, conceptually, we're constantly evolving, and talking about dystopia instead, it would be a huge dystopia if we would just put the bounty up today and then never revisit the incentives and what we define to be science at that particular point in time. Yeah, so no clear answer from me as well.
I think that was really clear, actually. That was an excellent answer.
I think the answer is going to be subjective. And so we're not going to come up with something objectively computable, but these are all very great frameworks to the extent that you can concisely describe some subjective criterion in a way that needs to, I guess, constrain the problem space or the phase space of all human actions. Like that's what we were trying to do when you're specifying like an optimization over what should people do.
Yeah, and humanism is the idea that we want to have healthy societies, we want to have vital people, we want to give every human the ability to flourish and realize their talents. And that has been the defining idea for not quite some time. And so that's why we do science on the hard science and the quantitative science. We're going to try to understand life, we try to build faster rockets, we try to explore the world that we're living in to like enable this world for our children and their children. So that is currently the objective function of science, but I don't know whether it's going to be it forever.
Can I have a little elaboration on that a little bit?
Yeah, I think when I was speaking what is the objective function of research, without really realizing in the moment that there is a clear distinction between research and science, like you stated. And so, I kind of think of, if we think of logic structures and how we can attribute meaning to things and build consistent grammars, right? So you can build a really extensive explanatory framework for something that has no paradoxes, no contradictions, but it's a pretty well-known result that you won't be able to explain everything. You can try to explain everything, but then you have to embrace contradiction, right? So separating out our mapping of meaning to the world, it's a little bit of model theory from Tarski. We're thinking about kind of maybe formal grammar systems, and so those are two separate, I think, ways of kind of approaching a problem. And in computer science, that's really important, right? So I think bringing it back into like real-world application, not just math theory or anything like that. How do we protect against, and this is a conversation I've had with Sarah, if you guys know her, Sarah Amber. How do we think of the edge cases and distinguish research from science, like flat earthers, or maybe like on one extreme, and then what about other forms of non-Western thoughts, like native forms of like native enlightenment or research or introspection? So I just wanted to provide that a little bit of a layer. Patrick, please feel free.
Yeah, sure. So to steal from Umar's presentation, I think earlier today, but a little less philosophical, but maybe to seek truth, like in theory, to create a framework that's repeatable in order to get data where you can make inferences about the world that others can independently replicate. I think the buzzword here that I love is the scientific method. And like, I think in general, society has a problem now with like establishing like what does it mean for something to be true? Like, I think academia now says like if it's highly cited, it's true. I don't know if that necessarily applies. So I think we do have a challenge in like trying to figure out what it means for like the output of a research project to actually be true, and establishing like a framework around that in order to have like a repeatable process that can get to the same like inference at the end of the project repeatedly.
Nothing is true. There's only falsification.
Well, I do come from the LSE, and there we had my philosophy department was founded by Popper, and so I do think I come from a Popperian approach to science. And so that's why the classification one was an interesting one. There was recently, when we wrote the book on gaming the future, which I'll be discussing tomorrow a bit, there's one really interesting trope on science as the ultimate voluntary consensus. And I think that's really quite beautiful. I think like if you trace all the way back to how science actually came about, then I think you do get into these like really, I think really quite beautiful like emergent phenomena that I think many of you guys are automatically replicating. So I think this like DeSci marriage is like a really natural one actually. And you know, I also I guess I'm somewhat still deeply Hayekian to the extent that I think that you know, competition is a really good discovery procedure, and I think to the extent that we can make that happen, and to the extent that we can keep it decentralized, we will find out better what works. And that's why I love what you said. Like if we could all now agree on one objective function, then we may not we may not be doing the right thing. But that being said, I think you know Evan's presentation, it was so interesting when you actually had the top down versus bottom up kind of juxtaposition. And I think that this is ultimately a really big question, right? Like we would all like to think everything happens in an ultimately decentralized way, but then there's also like, you know, DARPA, like and NSF, like people that just like take projects and then just like go for it, right? And like they just pick people, those people pick other people, exactly how he said this, and it's a cascade down. So I think it happens both ways. And that's why, you know, partly this tech tree project that we're doing is trying to mirror both of them. So on the one hand, we're mapping out entire spaces, like the spaces of longevity, the spaces of nanotechnology, and so forth, so that we can bottom up, just find out what are the labs that are working in these areas, what are the advocacy groups. But then on the other hand, we also want people to be able to chart individual paths to the forest by picking the projects that they want to support. And so that is the more funding method that is perhaps a little bit more top-down. And we actually had a ton of discussion around this of like, is it a tech tree, is it a roadmap? Because a roadmap is more top-down, where you actually pick an end goal, like I want brain-computer interface and I want them yesterday, let's make it happen. And then you kind of like, you know, regurgitate back to the tree. And so I think it's a really interesting distinction. That's why I think tech trees can do both somewhat, but you know, the whole road mapping efforts and the whole maps map challenge certainly has to grapple with it. So I think it's an interesting space, and to the extent that we have a good discussion about it, I think we have competing ideas and we're doing the right thing.
Yeah, and I love emphasizing that the U.S. government alone spends about $100 billion a year on scientific research. And if we're talking about like decentralized or peer-to-peer funding or like crowdsource funding, like it gets really hard to allocate anything on that scale in a peer-to-peer way. And so like leveraging existing systems becomes very interesting and very powerful compared to the other approaches you might take.
That's one.
Yeah, so those very interesting. Before I respond to that or say anything, I wanted to open up the floor to questions from the audience. I know there's questions out there. Please come up. It's wired. I can't come to
That
you.
microphone's live too.
Just a remark that I think you're making it a bit too complicated, because I think science is just a method, no more or less. And there's the Munchausen dilemma. You can look it up, but that's where you run into if you try to redefine a method. That's something that actually tells you what that method should do. It's like you're pulling yourself up in front of your own hair, right? That doesn't work. And Gödel also proved that if you have a really good system, there's also always something in the system that you cannot express in itself.
It's a really good remark, because it shows us how we're just limited in our ability to understand the environment in which we're living, and it goes to something I think that David Deutsch really also said in his book, and Chris talked to me about it, and Akash talked to me about it within the last 24 hours, so there must be something here. We're sort of in the pursuit of ever less complex answers to the phenomena that we're seeing, and we're trying to basically build an internal representation of the environment in which we're interacting, and it's actually an evolutionary process. The one that understands the world best can navigate it the best. And so in the Middle Age,
we didn't understand the natural world so well. We had scripture, and that was one of the core sources of truth, and it could explain a couple things. And then enlightenment came, and we started to ask some of the very hard, the very basic questions, and we started to find quantitative ways to think about the world. And we're just now in this sort of process of just iteratively getting a better representation space of the world that we're living in. And then that is still completely potentially flawed. It's not actual reality. We're still in the cave.
Yeah. I can say I'm not personally a huge fan of parsimonious truth, which is, I think, the David Deutsch claim, where like the more succinctly and likely something is to be falsifiable, the more, while still not being falsified, the more likely it is to be true. And like, it feels a little off to me. I agree with it generally. I would say that when I talk about science, and even I guess part of like talking about the objective function for science, or research, I think it necessitates a distinction between science as the process and science as the system in the world that runs the process. And everything I've been talking about for science or research, it's like it is the running of science as a process on humans as the hardware layer. And I think that requires some difference in, like, it becomes far more subjective. I can at least look at that.
Yeah, that's really interesting. I think like a lot of these conversations are probably going to be guided a little bit by some computer science theory, because we're trying to ask, how do we make a meaningful mapping between some object and its meaning or something like that. And like in science, I can try to do that. So when we think about models of general artificial intelligence, you might come across Aichi, AI. And in it, it uses a compression algorithm called Kolmogorov complexity to be able to sort through multiple different types of explanations. What Kolmogorov complexity is, it's a metric of the total number of information the procedure algorithm required to produce a result. So Aichi is able to kind of do research in its own way and find the right questions to ask or the right things to identify. But it uses a compression algorithm. So what are your thoughts about oversimplification in that class? And we don't have to go down that route at all. No one has a question, please raise your hand.
I'll just say I like that. That sounds really, really cool. At least it's at least cute. I have no idea how successful it'll be with it. Yeah, love to learn more. Do you have thoughts?
Well, I guess those are, not that detailed, but I think the same process of like centralized versus decentralized propagates if we talk about an artificial general intelligence versus more like a decentralized approach to AGI. And I think, just coming from a more futurist space, you certainly now have, I think maybe after Dsci, we'll have a really long, maybe after break. The next time we will all come together, it is when we're talking about different ways in which we can integrate AI more into the decentralized frameworks that we're all working with. And I think that's already happening. You're obviously working on this, but there's a few really interesting posts by Fred Erzam, then by Ali Yahya, and by Trent McConney actually on AI DAOs and federated learning and how they can integrate with each other. And so I think that to the extent that the crypto commerce space is trying to even decentralize the processes of AI, which we usually think about as single artificial general intelligences. I think even there we will be unpeeling a few more layers of the onion in that more centralized distinction. That was more a riff than a concrete answer, but here we go.
Come on, yes, speak to the mic. All right, we won't be on live stream.
It's not really a question, but something that caught my attention. Kevin said that humans are the hardware layer, so what do you say the software layer to?
Oh, in this case, in that case, metaphor, I describe science as the software that's running on humans. Like, it's a process in the same way that like weird bugs or quirks in the firmware can lead to the process not working well. We absolutely can, and I would claim do see that in science, where like reasonable people end up with unreasonable results because of some either like distributed system bug between multiple people, or some like intrinsic bug where you have like a cognitive bias that is just like a bug. I see cognitive biases as bugs in the firmware of humans, and like researchers have cognitive biases too. There's like some really interesting claims about how like going from like medical research to FDA approval requires some like weird epistemological shift where like as a scientist you're trying to ask and like acknowledge that you might not be able to know whether or not this thing has this effect, to like at the end of the approval process you're like trying to convince people that you know and have high confidence that it has exactly only this effect, and like that requires some like epistemological gymnastics in there.
Yeah, we tend to be very uncomfortable with ambiguities at a certain point, and it's actually something that I'm not that happy about, that we have these step functions along the way of like understanding something in the world, because the moment that the FDA slaps the label onto something and says, now that's approved, that's safe, silently questioning that truth becomes extremely dangerous. It's on a societal level, and not to become like political, but I think we need to get into the world, we need to get into a societal state where we are all way more comfortable with ambiguity, and I think the internet is painfully getting us into that state where we just realize that, oh, like, dang, there's just not a single source of truth. I cannot even trust like the state-funded media because maybe they have this bias, and I actually get access to all these different bubbles of reporting, and it's just all a big ensemble. And I think it forcefully trains a new muscle in all of us to understand that it's just different shades of gray, and that will probably also reflect itself in the way that we structure society, where we might be able to get away from having these step function like things like an FDA approval, where it will just be, this is just one of the supplements that is available. We actually did a trial. Now there's more data on it. Oh, we did another trial. It seems to be relatively safe.
Bayesian updates on
right,
trials.
Exactly. I want a website with like a Bayesian updated, like currently live meta-analysis for every substance that we take and believe that it improves human health. And I think we're getting there.
You want to be terrified though? I think it takes three trials that show a significant effect from the drug or the treatment in order for that to be approved, regardless of the number of trials that fail. So that should make you all very uncomfortable.
Did you have a question, Chris? More of a comment.
Yeah, so a couple of things I'd like to bounce on. So you mentioned skunk work, you mentioned DARPA, and we're also in the process of talking about how DAOs can help fund science and make, use the power of crowdsourcing to make better decisions. But I think we have to proceed carefully here, right? Because if we look at the history of DARPA, how they've innovated, they've given a whole lot of leeway to the capital allocators, which is very different to the way the NHS has been structured, right? Doing much more, proceeding in decision by consensus. So I think as in the process of thinking how we're going to be, creating structures to fund science, we have to be aware of, all these Chesterton's gates, that have been mentioned prior, and the way these systems, how they organize themselves for decision making, actually impact the type of science that's funded. So typically, the NIH does a lot of, low risk, minimal common denominator. Everyone can agree, but they're not going to go for like moonshots. Whereas DARPA is completely different. They'll say, you are empowered to make a funding decision. I will give you a massive budget. You're a very smart person. Go out there, find really smart people, and go for the moonshot.
You see this in venture too. Anywhere where you have huge financial returns for success against high risk endeavors, you see the mentality of fund people, not projects, show.
Yeah, so I think that's one part we have to be aware when we're building these funding systems.
Yeah, and look here, I can just go back to the meta point of we have now kind of competition as discovery procedure in the sense that we still have NSF, we have DARPA, but we also at a recent event where a few of us got together, which was like a FOSSET's annual member gathering, we had an FRO project, like a focused research organization, and then we had a PARPA, like a private RPAR, and there's a bunch of like, I think now, like gray areas, really like, which are like really, bridging the gap between the like entirely normal structures that we had and then the entire Dsci space. I think ultimately there's now a ton of different processes out there. And I think if you just look back at Eugene's slide and at his spreadsheet, like we're gonna find out in 6 months from now already, like the few systems that really like kind of like we're able to get a foothold, and maybe a few projects merge, maybe a few projects like spin out and make babies and have another few projects. And so I think this like meta process of actually figuring out like what are better systems. Now that we've just untangled or opened the box of Pandora, that hey, look, we can maybe produce better systems with which you can produce better science. I think it's going to be super, super interesting. And yeah, it's a great space.
So during the Vita-DAO presentation, they talked about kind of the process of like how they like consider different grant applications. And Chris brought up something that like we're thinking about a lot at Research Hub. Like, how do you have like community governance over funding decisions? Where is it better to have like the individual capital allocator, or is it better to have like consensus of a lot of different people, where maybe there's like expertise waiting? Curious what you think like is most viable, or maybe like different fields of science would require different types of like grant making.
I think you want a barbell test.
I think it depends on the field.
So yeah, I think it depends on the field, but I think also we would all benefit from a plurality of methods, and we should experiment. And I think that's one of the massive promises of crypto is mechanism design at scale. And we can experiment with different models, and we can check back 2 years down the road, see what has yielded the best results. And also, it's also fairly possible that the best thing is to have just a barbell strategy where we just have the two extremes and we test them out. We see what happens. And I think at the end of the day, it's going to be, a lot of it is going to be very field dependent. I can imagine that if you're looking at a problem at the time scale of the NIHS, maybe trying to solve something in the next 2 years is very different from the Foresight Institute, with a 30-year horizon. So it could be that or quantum computing that you're involved in. It could be like these moonshots that are really deep future tech require a different type of organizational system and incentive structure for capital allocation.
I really want to briefly describe my secret grant maker idea. So imagine telling a bunch of scientists who are in a generally uncollaborative field, like, hey, we're going to allocate like $5 million of funding in the next 6 months. We'll explain the rules, join this Discord. And then from that Discord, join this Discord by this date. At that date, you randomly select, or maybe you intentionally select 10 researchers, and you say, you are all now secret funders. If anyone finds your identity and reveals it to us, they become a secret funder and you stop being one. And you can fund whatever you want. Maybe if we had some tokenized IP strategy, it could be really cool to provide the funder with some project tokens from the project that they fund in return for funding it. But overall, you sign some conflict of interest assertion, and they can fund. They can recommend that me, the program, that the entity running this program, can fund. And the restriction is that you can only fund ideas that have been posted publicly in this Discord forum. And so now everyone who wants to get this funding has to discuss their ideas in a way where they don't know if they're discussing it with collaborators, they don't know if they're discussing it with antagonists, or they're discussing it with funders. And everyone has incentives to try to mask what role they're playing, so that everyone can be treated the same. And you could create new rules, but I think we need more mechanisms like this that are nothing we've seen and maybe empowered more by crypto, or at least the crypto mindset, than the kinds of things where it's oh, we'll do a call for grants, let's have a bounty program, something like that. I want to see real off-the-wall shit. And if you have ideas for this, come to me and I will try to find funding so we can run your weird experiment. Sorry for the shameless plug.
I wanted to ask another. Oh, sorry. I was just giving a short anecdote. At Vita-DAO, we're running 3 different mechanisms of funding. We work with Gitcoin to give scientists funding that do very basic research or open source maintenance. And I think for that, you want to have these sort of democratic voting systems. And then for, I think the type of science that is currently underfunded, it's the type of science that can lead to an actual invention, technology potentially,
but it's still too risky to get VC funding because we are living in a barbell world right now. That's where we bring in these IP NFTs, you get some kind of ownership of the IP, but it still feels a bit more academic. And then the third bucket is equity funding for startups or prizes. We haven't gone like completely crazy with mechanisms, but this sounds very interesting.
And so I just wanted to ask a question about the culture of science, because I think that even if this community comes up with the right processes and all of the right tools that have been missing, I'm just guessing that that's not going to be enough for science to just be magically fixed overnight and everything works wonderfully. So I was wondering, from your perspectives, what do you see as some of the cultural shift changes that might be things that we should start thinking about now and kind of start slowly chipping away at that to make it easier so that when we do have the right tools and we go through the rounds of experimentation so that those tools are actually ready to be used by folks who are currently in the power in the structure?
I have a bit of a, I'm just going to jump on this. I have, I guess, a very quantitative or like non-social answer to this, which is this Berkshire wisdom, like showing the incentives to show the outcome. Like, there's no like culture. It's just where does the money come from? Where does it go? Where's the mechanism in which the capital is allocated that will shape this behavior of a large group of people? And currently, it's a committee and a committee of committees. It's allocating taxpayer money, and you just try to like rise through the ranks of that like ministry, basically, of that like system that has emerged over time, and that creates your role in this market. That basically is that's the basis of how much power and capital you can control as a scientist within these government-funded agencies. It's $80 billion across major entities. All of the private research institutions can't compete with that. So this is the way that the NIH and other agencies allocates capital is shaping the culture of science. So change the capital allocation mechanism, change the culture. That's one way to answer the question.
I'll be brief. Definitely not a monolith, and there are more incentives than just money. So like to the extent that science could be considered broken, and you could also consider those other incentives also broken. But I'd love to see like a prize for the grant maker that gave a grant to the most innovative thing that worked out, just so you have an incentive for grant makers to try and take risks in addition to the researchers taking risks.
Yeah, so to kind of build off what Nick was saying, like when I was in grad school, I know people kind of measured their success by publications, because like the job market's so competitive, like you're gonna like try and get a job as a professor eventually. So you kind of have to have this like resume of publications and citations in order to like just have a career in science. I guess I'd push back a little bit where I think there's a culture shift happening right now, even though like the financial incentives haven't been fixed in like the open science movement, where there are people who I think a lot are like well established in their careers, but like they are like purposefully like eschewing high impact journals in order to publish in places like eLife, where they may get less citations, but their science is actually open. And so there's like a cool I guess like ethos developing where like people are like consciously ignoring some of the financial incentives that exist. And I think like the cool thing that like blockchain could do is help to align like these like long-term like career stability, metrics with actual like behaviors that are healthy for the research ecosystem in general.
Do you think that increased VC funding or increased availability of VC funding has led to part of that shift, to the extent that like if you're not publishing big things, you're publishing big journals, publishing important things that have applications, that you like there's a new incentive path that you can follow instead, and so it's good for science, but not necessarily a different incentive.
Yeah, it's definitely possible. I don't know that much about how often like science papers end up getting like VC funding, but I can see it.
But then also now you have a move away also from like VC funding, also more crypto funding is now also becoming relevant. That gives a host of other new incentives, right? And so people are really like, I think like totally feeling that way as well. So I do think that they do go partly also where the money goes. But I did want to come back to the culture question, because if you think back of the Meditations of Moloch post actually from Scott Alexander, he actually goes through science as one of the models. And I think the interesting thing is that I think he says in the post, I don't know who here knows about what we're talking about. Meditations are models. Okay, good. But anyway, like just to be really quick about this, because it comes back to the culture. Like he says basically something like, if a science club that stood outside of science could just go in and establish replication markets and do all of these things. But like on the other hand, we also have to understand that it's pretty good that there isn't a science god. Because if there was a science god, it could operate like the science god operated in Nazi Germany, for example, and fund stuff that really, like most of us really don't want, right? And so I think it is part of the robustness of science as well, that it is this volunteer consensus of a bunch of people coming together and over time figuring out what works and doing this really in this extremely collaborative way that I think we are all here like because purely we want to collaborate. And I think that this is ultimately what makes science robust over the very long run, right? That we can critique and so forth. So I think like, just fixing it, or just installing a culture shift, I think, also is part of an evolutionary or a discovery process, I think, in that regard too. So I'm quite happy we don't have a science god yet, and we can do it amongst ourselves. And I think that's good enough in the long run.
Yeah, and maybe one more thought. You pushed back when I said that it's only the capital flows, and you're absolutely right, because I think technology, especially communication technology, changes our action space, and suddenly you can post something on the bioarchive or just on the web. You can pin a PDF basically out there, and that changes the action space, and the cost of sharing it with the world drops. And then there's like, the funding is still dependent on whether you made it into Nature, and it's not really dependent whether you're a hit in the bioarchive, but you start to ask yourself why. so there's possible states that you can choose, they are opened up by new technology, and then culture changes, and then hopefully capital flows change, and they're somewhat reinforcing.
I love the model of science as a conversation, not as a tree of knowledge, and where conversation topics enter and leave. I feel like that's really explanatory for things like this.
Yeah. So that's an interesting thought. So going back to kind of capital inflow into science, I think maybe I don't know, maybe I'm wrong, but maybe a desired outcome would be that capital traditionally considered, once it enters science, ceases becoming capital. It isn't just like money or USD. It's maybe perhaps benchmarked against a different value, right? Where we start thinking of kind of like Ethereum commoditized computation. What if, and maybe the right answer has something to do with kind of the decentralization of these abstract concepts of how we think about these commodities, whether it's right now data. I think Protocol Labs does an amazing job really hammering out, incentive engineering mechanism to commoditize data and really converge down to a local minima for the cost of storage. So, I think like right now, even in before VCs come into DeSci and they find their pet projects and they come up with like the next version of Research Hub or something. I'm sorry. Is that the right one? ResearchGate. I'm so sorry. That's the one I was ResearchGate. Where it's a Research Hub is Web3. It's a tokenized ecosystem. ResearchGate is a Web2 system. So yeah, thinking of kind of how, before they even come into it, how do we think of the power of tokens to to be able to create abstract representations of things that didn't have value before, like a data set or a service like Nicholas is working on, or perhaps other things that might be identifying in science. So,
one thing I think about a lot here is like authorship credit. Like in theory, if I have a data set that I put out there and somebody else publishes a paper, I can become an author on the paper and add to my CV as a publication. Something that would be cool is if that was a little bit more like delineated and official, where if I use your data set, there was some kind of token compensation for that, that was associated with the actual work you did to produce that knowledge. I haven't seen anything like that yet, like tokenized authorship credit, but I think it could be kind of cool to help, like, compare tokens to effort more so than money.
Maybe I'm oversimplifying here, but I think at the end of the day, what we're creating with DeFi is we're creating topology, I think called like the DeFi matrix, you can just swap every token and every other token. So yes, we are able to capture things in tokens that have not been able to be captured before, but they also can be swapped into USDC.
Yeah.
So at the end of the day, it all can be condensed in one number, which is like information compression. Like, is it worth something? Well, how many dollars is it worth?
Even if the benchmark changes.
Yeah, and I mean, it's not very romantic, right? Like you can swap every token into USDC, but yeah, I think that's the way it is.
I think that's a very effective and valuable compression. I do agree that it's a bit lossy. I think that what you lose is that not everyone would value it the same amount. And the value could be expected to change over time because like combination of value is non-zero sum.
There's been, I think folks have kind of touched on this in this discussion of the objection function, but I'm curious what you think about sort of the legibility of the inputs into this objective function of science, right? We talked a little bit about citations, authorship, maybe nodes on a tech tree, maybe sort of services rendered on Lab-DAO, but I'm curious whether sort of a push maybe in the decentralized science movement to have greater legibility has certain trade-offs, especially if we consider the importance of perhaps subjective factors in this objective function that sort of Evan touched on earlier.
By greater legibility, what do you mean by that?
Legibility as in, I guess in some sense of whether, if we imagine science as this open-ended, sort of curiosity-driven discovery process versus something that is sort of highly legible in some sort of intelligible format, maybe, research of upvotes. Is there some trade-off that occurs that makes it more difficult to kind of reach our utopian vision of what science should be?
Can you clarify objectively or subjectively legible?
I'll let you interpret it as you wish.
To me, this is like the coolest part where DAOs come in, because like upvotes probably aren't a great way to like determine the value of like a research output. Like just like citations aren't a great way. Citations are probably better than upvotes. But like over time, you can look at like the ecosystem as a whole and try and like tease out like what are the metrics that actually cause like whatever KPIs we end up deciding are important for like research, and then figure out like when you tweak those, do you get more of what you're looking for at the end of the system or less? And like you can even do experiments to see how you can change. Like maybe it's like page views, not upvotes. Maybe it's some combination of like how many products came out of this. Divided by like how many people went to work on it or something, And with DAOs, you can have like a crowdsourced decision-making process where there's consensus on like, hey, what is value? And does it actually help us achieve what we're trying to get at the end of the process?
I do want to say though, I think a really big trade-off is getting the folks that are interested in crypto and tokenization and getting the scientists. Because let's face it, like especially if I look at our molecular machines group, I would say maybe 5% are whole crypto of these scientists, right? And many of them have not heard about Dsci. Many of them don't necessarily want to engage in it, right? And they shouldn't, right? But if you want them to do due diligence on stuff, or if you want them to be able to, easily do project proposals, if they need to be on, have a MetaMask wallet to like maybe participate in the Gitcoin runs, that is already like somewhat of a gateway really. And so I think the big trade-off is like how easy can you make it, and how much of an on-ramp can you provide so that they can focus on what they're good at, which is the science part, and we can have everything in the back end. And this is something that we face every day. Like because I'm always at the intersection of trying to matchmake between like really like just like scientists that are deep in the nitty-gritty and then like a bunch of funders, and like the funders want all these super elaborate crypto mechanisms and like want to figure out exactly like what this division that you references, and but it's difficult, right? Like to onboard the actual scientists that are just out there and want to do their work and get it done. And so I think providing somewhat more of a loop between that, I think is kind of our role in this process of it.
Allison, you're a market maker.
Yeah.
You're a broker. This is your job, right? So what is the when is legibility not productive or productive? Maybe I misunderstood your question, but I think there's this just constant dilemma between you basically have the population, and the population function as a market, it determines the value of something. And then, however, when you reach the bulk of the population, the legibility has been simplified. So maybe some of the information has been lost, but then you have the biggest group of people that can interact with that piece of information. So that's kind of a dilemma, right? and a simple answer to that is technology. So you don't actually have to understand how it works, but here's the iPod. And I think that's probably the most effective way to capture value out of scientific insight. So you don't need to be the broker of being in the business of writing books that explain the technology, but you can actually just build it. So at Bell's Labs, there was this quote, you haven't invented anything until you sold it. And I think that's just the easiest way in which you can share knowledge with the world in the moment that we extract it into a technology that can be sold, and there's a value chain evolving around it. And so ideally, the knowledge does not get lost.
Yeah. So just interject a few things there. So first of all, thank you, Alison, for being the market maker. Also, Patrick, for being the soft on-ramp for scientists. I think that has a huge value for the whole Dsci space. And finally, I just want to bounce back to this question of metrics and credit, and maybe to go to a little known fact. Right now, you can think of the scientific record as a series of cloud databases that are owned by big publishers and that actually have a meta-curator. And the meta-curator is the one that controls the write function. It's basically indexing the journals. In other words, it's controlling who gets to write on the scientific record. And that particular entity is Clarivate Analysis. It's a multi-billion-dollar company. And Clarivate Analysis is the issuer and all the scientometrics behind the scientific record. So that is the company that is counting the citations and through Thomson Reuters issuing the impact factor. So Clarivate Analysis controls the write function of the scientific record. Elsevier in 2005 tried to compete with Clarivate, and they came out and with Scopus, which is an alternative indexer of scientific journals. But right now, the whole equilibrium point for all scientists, I mean, I assume maybe not all of them, but most of them, is that they converge to the impact factor as the metric for allocating resources. And it's controlled by one company. And that's insane. Who wants that? So I think, one of the big hopes behind Dsci is actually, can we reclaim the write function of the scientific record? We all agree that the read function should be universal, that everyone should be able to have access to read, should be monetized. But the write function is the more pernicious problem because they decide the incentives that flow downstream towards everyone else. And they're selling to funders. That's their business model. They tell funders how well they've performed with their allocations. That's Clarivate Analysis. So the whole system of science has this, incredible centralized gatekeeper at the very top, which very few people know about.
I was a bit of an emotional reaction to one thing you said. Sorry. Our job is not to define a new function. Our job is to enable multiple functions. And also to recognize that it is not Clarivate that defines the direction. Clarivate is just a pawn in the system created by huge tax money allocating agencies. They just won the government procurement contract. They just help make the decision in an agency that wants to have a very easy answer on who is a good scientist and who should get funding and who is a not as talented a scientist and should maybe not get funding. So long story short, it's decentralized capital leads to decentralized finance, leads to decentralized capital allocators, leads to decentralized science, leads to multiple versions of what the objective function should be. And that is a beautiful evolutionary process. And I think we might move in 20, 30 years towards a new state of equilibrium where we'll have new like clarivates in town. But that's, I think, just the nature of human civilization. You either die a hero or you're long enough road to be the villain. So we're, multiple clarivates. That's what we're working on.
Completely agree. And I think just to dive a bit deeper in this rabbit hole, it's also interesting to know that it all came down from Eugene Garfield, who was a sociologist, an American sociologist during the Cold War period. And he was tasked to figure out, how do we allocate money? How does the government allocate money? And he came up with the field of scientometrics, and that led to impact factor down the road. And these are the foundation of the whole building blocks of our scientific ecosystem. It comes down to this sociologist.
I always think I'm not jealous of people who have to give grants out at the NIH and SF, because how do you determine the quality of the scientific study, right? I think citations are kind of this metric of convenience, just because it's an impossible question. And so at the end of the day, what is a quality research output? And how do we get funders to want to fund quality, whatever metrics those are? How do we convince funders that they should be using those rather than convenience metrics like citations?
I think a low-hanging fruit is reproducibility and replicability. I think, citations, when impact is decoupled from replicability and reproducibility, we end up building houses of cards that all come crashing down. So that is something that funders should be, paying attention. But in order to pay attention, you need to have the data coming in. And right now, today, if I look for studies and I'm looking for, has this study been replicated? I have to go through all the citations. I mean, every study that cited it. It's extremely difficult. There's no legibility on figuring out what is reproducible and what is irreproducible knowledge. And one of the big problems is that nobody in the value chain of science has any interest in letting you know this. So why would a publisher of a prestigious journal write on top, of the paper, this study has been shown to be irreproducible? They lose prestige, right? They have no incentives. They're even bad with corrections, right? Try issuing a correction. Sometimes, you might have made a typo in some plot. Issuing a correction is a process in itself. It's very difficult. So yeah, there's a long chain of players and incentives here at play that are dynamically interacting.
Yeah, so it's interesting because there have been some meta-science studies that have looked at journals by impact factor, and the higher impact factor, the less likely the paper is to be reproduced. Because this journal, it has a subscription model. It needs to put out entertaining research. It's almost like a clickbait effect, where the smaller journals where there's less pressure, the findings don't have to be quite as exciting, and so they're actually more likely to be true. And at the end of the day, it's still funders who are funding projects that have researchers with lots of citations. So yeah, I think it's the funders at the end of the day who have the responsibility.
It's the funders, but there's also the fact that irreproducible studies get cited more often than the ones that get reproduced, right? Because of the lack of discoverability.
So I do want to add that there's at least one group. Is it Arcadia Science Research? Arcadia Science, thank you. Where to join, you have to promise not to publish in any academic paywall peer-reviewed journals. And so we might not have to wait 20 to 30 years to see a world that does not require publishing as part of the loop of innovation. It'll just be interesting to see how fast that can grow. I also think that there's a super interesting sci-fi future where instead of GPT-3s explain it like I'm 5, we have a mind-numbingly good GPT-7s explain it like I'm Evan Miyazuma. And once you have that, then I can get any paper or book or anything and get it expanded or contracted to whatever I need to match my context, meet me where I am. And I am now no longer reading journal papers. I am now reading syntheses that are automatically generated for me. If you have that system, you also don't have to write journal papers, because you could say, here's an idea, you have my context, reformat this for this particular journal, and on the other end, you expect people to be able to use the same technology on the other side. So the academic discussion becomes an overlay network on the journals that you could just like trivially switch to like an archive preprint server and not see much difference as soon as you have useful metrics on accountability and trackability and all these like weird Dsci native, easily like reasonable things that are separate from the journals. And so I'm like excited about getting to that kind of future and merging these kinds of technologies.
But what you actually want is just a DCI that can just give it to you straight. No, just one really quick point. I think it's all again trade-offs here, in the sense like science is already like really difficult to do, especially early stage, and it's really, really, really hard, I think, to get right. And I think ultimately, you know, like that's what you guys are working on, right? Replication markets, and I think like that's clearly, you know, like great, you know, prediction markets, replication markets, in particular, yes, that is totally, I think, something that we should be aiming for. And amongst like many, like again, like I think amongst a sea of individual projects that are all, I think, already providing competition for the current way in which people try to signal that they're producing good science. And I do think that there is always a trade-off by like trying to construct, you know, systems that get the science funding correct, in the sense that if we add very high complexity here to like a very complex science project that is already very early stage, I always wonder, oh my God, like, do I actually want to, like, for many of the scientists that I'm trying to service, how complex can I make it for them? You know, like, how complex can I make, how much can I expose them to the early experimentation that we are in? Obviously, we would love to have really great projects in early stage science that already jump ship as soon as possible into the systems that we're building, but they are already working with really different stuff. So I really think like maybe it's my like individual bias, but trying to like, you know, get these complex systems working, like put it up while you're also doing this thing over here that's really complex. Anyway, I think we're certainly learning a lot, but it's hard to combine the two, you know. It's difficult.
I guess I'm kind of speaking my own book here, but I think giving scientists the financial incentive to concentrate capital independent of grants by exposing their product as an API service, be that theoretical, computational, or in a wet lab context, is a really simple way to incentivize reproducibility. Because if you do reproducible work, you can make money doing it for others. Surely that does not work for every kind of science, but I guess as a training in medical school, I have a very like purpose-built view of science where it's more about technology. Like science can be in many ways the foundation of technology, and then if I develop technology, ideally that can just be the chaining of API calls. So I want to fold the protein, and I want to dock the protein to the antigen I want to target, and I want to clone that into a backbone, and I'm going to transfect that into a T cell, and then I want to inject that into a patient to cure a disease. That's like ideally that's the future where that is a script that I can basically just ping different scientists APIs, and then they will in the future receive funding based on the on-chain record of how often their APIs are being called. So like, wow, you are adding so much value to the world. Like, I want you to be able to do work and get the next API out and running.
Yeah, so we're just amazing conversation. I've just been hammering away on my keyboard over here, and I hope we'll have some follow-up conversations in future sessions. We just have a couple minutes left in the session, and I want to encourage anyone who's shy to come up and ask a quick question. Please, Mo.
So I am also really enjoying this panel, and I'm sad that it sounds like it's ending soon. But one question I have is, what is the role of education in science? And if you don't share your discoveries, do they contribute to science? Like if Charles Darwin never published Origin of Species, would it be science?
I think it's kind of hard right now because it's like if you publish a negative result, it actually hurts your career. So like there's this weird system where like we want researchers to share stuff that like will hurt them long run because it's good for everybody. And like I've had friends who have been like told to reproduce studies and like left grad school because they were unable to reproduce studies, and it turned out like the study was actually fraudulent at the beginning. So like yeah, there are a lot of issues.
Yeah.
Well, I mean, I think it would be, and I'm maybe going back to the secret formula model or something like that. Like, if you can create incentive mechanisms by which people are incentivized to actually share when things don't work out. Currently, there really aren't any. Like, even if you just look at all of the potential attempts that have been submitted to the FDA, all of the ones that don't make it through, not even that shared. Right, that would be a big learning curve for some people. Like, what do I even submit there? What don't I submit? Like, and so I think the more we can privatize and anonymize these like data sets, I think the more we may be able to incentivize folks to also share this, especially if you could, for example, put bounties to sharing individual data sets which didn't go well in an anonymized way. So they may be not immediately, I guess, traceable back to you. Maybe on the long run it would hurt you, but like getting better at those incentive mechanisms would also be really good, because then we learn all the things that didn't go well. And that's really difficult. But I think I talked earlier to Dana over there. We're very excited both about federated learning and Open Mind obviously has done like insane research there. And so I think that, even here we may be able to come up with a few ways in which you could on the long run even learn on these data sets. I don't know. This is all like very, very long stage in this like other stream that I haven't actually heard very much about yet, but that's maybe something for someone else to take on here if they are still looking for a pet project.
I know we need to wrap up, but I think it's actually maybe closer than we think, because the moment that any trace of the scientific process itself that has led to a negative result is left on chain, you have the chance to ask the uncomfortable question: whatever happened to that protein you wanted to dog against this antigen? Why did that not lead to a particular drug or a particular publication? Why did that never make it into your IP NFT that you then published in Science? And if that happens often enough, there will be these sort of dead ends in this sort of directional graph of like certain scientific services that are invoked, and that will raise questions. So I think the moment that we can engineer a mechanism in which at least some of that scientific process leaves a trace on the public ledger, and we might be able to solve that problem.
My personal opinion is that if a discovery doesn't make it into doesn't have impact, it may as well not have been made. I do think a lot of this stuff around falsification is really interesting and really valuable, but there's also a fantastic PhD comics comic about how this nameless grad student goes in and says, I wasn't able to do the thing you asked, it's impossible. And the advisor says, you being unable to do it doesn't mean it was impossible, it just means it was impossible for you. And I feel like that is a surprisingly difficult epistemological question to address when it comes to falsification and negative results. And I do think that having incentives for more robust and more honest and like candid, direct interaction between scientists is probably the best way to solve it, because as long as you have something you want to hide or you want to mask as something else, you probably will be able to do so given the number of variables and the complexity of the system. So building culture, building incentives seems far more valuable than necessarily just going with tools on it, I guess.
That's yeah, couldn't say better myself. Thank you so much to our panelists. We do have to wrap up, so a round of applause for them. Thank you guys for coming. Yeah, so the recordings will be live. We'll post some notes too on this conversation, and looking forward to tomorrow. We have tech trees. We have the book.
Tomorrow at 11 a.m. it's more decentralized approaches for reducing some of the risks that arise from Dsci, and then I do a tech tree one session on Wednesday at 9 a.m. and Eugene can probably tell you more about his upcoming projects. Eugene, what do you have cooking?
Yeah, so first off, we're going to be doing a social in however soon 5 o'clock is at Lowdown Brewery. I'm looking for coffee. Yep, Lowdown Brewery, which is close by. So tonight we'll be doing that. Then tomorrow, Allison mentioned her event with Foresight. Right after that, we're going to have 7 panels focused on DeSci on different projects, roughly half of them. I'll be presenting on SCRF, then it'll be 3 projects using Web3 for science broadly and 3 projects in the Web3 research space specifically. And then on Wednesday morning after Allison's event, we'll be doing a panel where we'll have an independent researcher presenting, then we will have a panel on how to provide peer review for independent researchers, and then we'll actually do small group breakouts to discuss more focused questions around realigning incentives around both research and review. So yeah, those are the fun events this week, and yeah, a lot more to come beyond this week too. Yeah.
And you can all find them on the schedule. They're all DeSci at EthDenver. Like they have that as a sub header.
That's right. And if you need access to any of these links or resources, just come find us or find anybody with a blue shirt or a SCRF shirt, and you'll grant to that. So one final round of applause for our panelists.
Shadi, thank you so much.
Time for some beers for some of us.
Yeah.